Okay, we're moving on to lesson 2, reflections and stretches. I don't use the workbook for this. I'll assign the workbook for your homework, but I'm using my own note package for all of your notes on reflections and stretches. So make sure you have this. And the blank note packages are on the Google Classroom. This lesson 2, will be a 2-part video I'll make for this. So this is part 1. Okay, part 1 is going to be dealing with reflections, which again was briefly introduced in Math 20-1, and then we'll get into a lot of detail in Math 30-1. So what a reflection is, a reflection of a graph creates a mirror image in a line called the line of reflection. So reflections, like translations, it does not change the shape of the graph, right? So that's important. Reflections do not change the shape of the graph, just like translations. Translations move the graph. This is going to reflect the graph. It's not going to change the shape of it. However, unlike translations, what's happening is the orientation of the graph is what's changing. Okay. So there's 3 different types of reflections that you need to be familiar with in this course, and those are going to be vertical reflections, horizontal reflections, and reflections in the line y is equal to x. So let's start out with what a vertical reflection is. So you know that a vertical move from translations is an up-down move, right? That's what a vertical reflection is. So let's say I gave you the point 3, 4. So 1, 2, 3, 1, 2, 3, 4. So if I gave you this point, 3, 4, and I said, have this undergo a vertical reflection, basically what you're doing is you're taking this point and you're reflecting it down. You're reflecting it down. And then I would say, okay, what axes is this a reflection in? And the axes that it's a reflection in, it's the axes that I cross. So a vertical reflection is going to be a reflection in or about, we say, the x-axis. So again, we could say a vertical reflection is a reflection in the x-axis, or we could say a vertical reflection is a reflection about the x-axis. So this point 3, 4, if this was my mirror line here, what my new point would be 3, negative 4. And what you need to sort of realize with vertical reflections, the big thing is going to be it's the y coordinate that changes. So what happens in a vertical reflection is y switches with negative y. Okay, so what happens is we have our original graph, which is y is equal to f of x. And under the transformation of a vertical reflection, this y is going to come out, and I'm going to replace it. The replacement notation is y is going to be replaced with negative y. Now, if you see your transformation written like this, you say, okay, that's a vertical reflection. Y was replaced with negative y. Or another way that you'll often see this is you know that this is really a negative 1. And sometimes we like to isolate y. So if I divide that by negative 1 and this by negative 1, y is equal to negative f of x. So if you either see negative y is equal to f of x or y is equal to negative f of x, that is a vertical reflection. Okay? The mapping for this would be x comma y goes to x comma negative y. So in vertical reflections, we take our original point, and when it gets reflected in the x-axis, my y value becomes negative. That is a vertical reflection. Okay, let's take that exact same point, 3, 4. 1, 2, 3, 1, 2, 3, 4. So 3, 4. And let's say I said I want that point to undergo a horizontal reflection. The horizontal reflection, my mirror line, is now this line here, my y-axis. So I'm taking this and I'm bouncing it over here. that would be a horizontal reflection, right? That's a left-right move. So what do you think, which coordinate is going to become negative? 3 or the 4? And if this is my mirror line, it becomes -3, comma 4. So if I'm just moving this point over here, this point I move down, right? If I'm moving that point over there, my new point is -3. The y value does not change. -3, comma 4. So with a horizontal reflection, it is the x value that changes. Okay, with horizontal reflections, you need to know what axes did we cut. So it's a horizontal reflection about the y-axis. So we'd say horizontal reflection about the y-axis. Okay, now what did I replace? What's my replacement notation? X to -x, right? That's my replacement notation. So x is going to -x. So in my function, y is equal to f of x, what I need to do for my transform function, if it's undergoing a horizontal reflection, is take that x out and f of -x. So if you're given this in a question, you say, oh, okay, my x value was replaced with a -x. That is a horizontal reflection about the y-axis. And the mapping for this would be x comma y to -x comma y is your mapping. Okay, the last type of reflection, which I'm going to introduce very briefly, but this is going to be, just make a note of this in your note package. It's going to be in lesson 5. So it's a reflection of the line y is equal to x. If you go to your graphing calculators, and if you graph the line y is equal to x, here's what you would get. This is going to be our mirror line. So this is our x-axis, right? This is our y-axis, and this is the line y is equal to x. So this is going to be our new mirror. If you needed to ever graph, like, well, what are the coordinates of this? Remember, you could just go to second function table, and when x is 1, y is 1, when x is 2, y is 2, x is 3, y is 3, so on and so forth. So that's the coordinates for the graph y is equal to x. Okay, so let's do a point, and let's do that original point that I had given you, 3, comma 4. So x is 1, 2, 3, y is 1, 2, 3, 4. So that point there is 3, comma 4. Now, it's really interesting, and students actually, when they get the hang of this, they really like doing these reflections in the line y is equal to x. What happens when this becomes your mirror? And I said, okay, well, what would your new point be? It's really interesting what you do. What you do to get your new coordinate is you simply transform x and y. So my new point, so my original point was x comma y, and when it's reflected in the line y is equal to x, my new coordinate is actually going to be yx. So let's see what that would be. 3 comma 4 was my original point. My transform point would be 4 comma 3. So 4 comma 3, let's see, my scale's a bit off, would be right here. And yeah, the scale is slightly off for this. Let me actually just maybe move this slightly. Oh, it might be locked in. Yeah. And so what happens is this green point is a reflection of this blue point in the line y is equal to x. So the line of that graph is y is equal to x. Okay, let's apply this looking actually at graphs. Vertical reflection. So I do a few things when I do vertical reflections. I always say, okay, what move is a vertical move? It's an up-down move, right? So get in the habit of drawing yourself a little Cartesian plane, and I just say vertical is this, right? It's taking that point and moving it up or down, right? So it's an up-down move. If I do that, I could see what axes I just crossed. So vertical reflection, and then I'm going to write in, or you could use the word about the x-axis, whatever axes we crossed, the x-axis. Then I always like saying, what was the replacement, right? Which coordinate stayed the same and which coordinate became negative? And when you move down and cross the x-axis, your y value was the one that was replaced and became negative. So y went to negative y. So then I always like saying, okay, y is equal to f of x. That was my original graph. So my transformed graph, I need to take this y out and put in a negative y. So negative y is equal to f of x, or y is equal to negative f of x. Okay, so this or this is a vertical reflection. So it says, given the graph of y is equal to f of x, graph the functions y is equal to negative f of x. So I'm actually going to cross this out. So if you see this, you just need to be able to look at that and say right away, oh, they want a vertical reflection. And then the mapping for this, let's quickly do the mapping. It was x comma y, and what it was mapped to is x stays the same in vertical reflections and your y becomes negative. Okay, so here they've given you the coordinates of A, B, C, D, and E. So they're saying if I look here, this is my f of x, my A coordinate. They're telling me my A coordinate, the x value is negative 4, and they're saying the y value is negative 3. Okay, so negative 4, negative 3. What is the new coordinate going to be? What is the new coordinate going to be when this undergoes a vertical reflection? So the only thing that changes is the y coordinate. You always give the opposite y coordinate, right? So negative 4 comma negative 3, the new y coordinate would be negative 4 comma 3. And my original point was A. My new point I'm going to call as A prime. So this point here, it's going to get reflected in the x-axis. So it's going to go up to here. The x value doesn't change and the y value bounces from negative 3 to 3. So my new A prime is right here. A prime. Okay, let's do B. So here was B. And they said my B coordinate was negative 2 comma negative 3. Well, what is my new point? It's going to be negative 2 comma 3. And that's going to be B prime, right? The x coordinate always stays the same and the y coordinate becomes the opposite sign. So a negative 3 becomes 3 because this is going to get reflected up. So that's B prime. Okay, C prime. Or sorry, C. C was 1 comma 0. So here's C, 1 comma 0. Something interesting is going to happen to here. The x stays the same, and the y, if you put a negative in front of 0, negative 0, that doesn't change it, right? So this coordinate, which is C prime, it does not change. And we're going to star this because this is going to be a really important concept. So let's star this. This now is C prime. So it's both C and C prime. This coordinate did not change, right? And there's going to be a word for that. Okay, D or D. D is up here. And we're going to reflect it down, right? So let's see where D goes. They said that D was at 3 comma 4. The new coordinate is going to be at 3 comma negative 4, and that's going to be D prime. So we're reflecting it in the x-axis. We're bringing it down to 3 comma negative 4, D prime. E is right here. So it's at 5 comma negative 4. The new coordinate is going to be 5 comma 4, and that is going to be E prime. And this guy bounces up, right? So it's going to go to from -4 to 4. So that's going to be my E prime. Then I'm going to take a ruler and a different color pen, and I'm going to connect my dots, and this is going to be my transformed graph. So A goes to B goes to C, sorry, A prime goes to B prime goes to C prime goes to D prime, and D prime goes to E prime. So this transformed graph would be, let's write in pink, y is equal to negative f of x, and that is a reflection in the x-axis. Okay, so remember how I said we starred C? What C is, if we have an original coordinate and the transformed coordinate doesn't change, what we call that is an invariant point. So this is going to be an invariant point. An invariant point is any point which remains the same after a transformation has been applied. You might want to highlight invariant point. It's just like such a big concept that continues throughout Math 30, okay? In this case, our invariant point was C to C prime, right? It did not change, so C and C prime, they were my invariant points. Now, what's important to notice, so it was 1, 0 to 1, 0. So what's important to notice is with, and let's star this, with vertical reflections, the x-intercepts are invariant. So if I give you any graph, okay? So let's say, I'm just going to quickly draw a graph. Let's say it's just a straight line, right? And I say, where on this graph would the invariant points be if this graph undergoes a vertical reflection? And the answer is this guy here will be invariant, right? That's my invariant point. And so it says, are there any points which remained the same after the reflection? And that was the x-intercept, right? That's going to be our invariant point. And the reason why the x-intercepts are our invariant points is because the x-intercept, no matter what the x value is, the y-coordinate is always 0, right? And we know that we're going from xy to x negative y. So how could you have whatever your x value is, -0, right? -0 is just x comma 0. So this did not change. Therefore, the x-intercepts are invariant points. So therefore, 1, 0 or any x-intercept is an invariant point. Okay, let's do a horizontal reflection. Horizontal reflection. So what do I always do for horizontal reflections? I do a dot, and then I say, I know a horizontal reflection is a left-right move, so that dot has to go over here, right? Once I do that, I say, what axis did I just cut? Horizontal reflection, it's a reflection in or about, so I'll just say about the y-axis. Okay, from here, I always do my mapping, right? Which coordinate, if this is x comma y, what became negative? X comma y. If we do a horizontal reflection, the x becomes negative. Negative x to y. So that's going to be our mapping to get our new coordinates. And then I always do the transformation. So, oh yeah, so sorry, x is going, so the replacement notation, x is going to negative x, right? So that's what's happening. X is going to negative x. So let's draw our original function, which is y is equal to f of x. And the transform function, once it undergoes a horizontal reflection, the x comes out and it becomes y is equal to f of negative x. So again, I do all of that, and just because then we read this and it says graph the function of y is equal to f of x, or sorry, f of negative x, then I know I know everything. I know that this means it's a horizontal, that the replacement is x is going to negative x for my mapping. It's about the y-axis, things like that. Okay, so I'm just going to pause for 1 second. Okay, sorry about that. I just had an interruption. Let's finish where we were. So what we're doing is we're going to be taking this original function and we're going to be doing a horizontal reflection. So let's look at the first coordinate, which was A. And A, they said, is at -4, -3, which is correct. And we know that with a horizontal reflection, our x goes to -x. So our new coordinate for A prime is going to be 4, -3. That will be our new coordinate. So that point gets reflected to here. And it's going to be really important in this example where you keep your A to A primes labeled, because this one's going to look a little bit messier than the previous example. Okay, B. So B is at the x value is -2, -3. So that point, the new B prime point, is going to be 2, -3. That will be B prime. C prime, 1, 0 was C. So C prime is going to be -1, 0. So -1, 0. So this point, right, was transformed over there. So this will be C prime. So A, B, C prime. Here's D, it's at 3, 4. D prime is going to be at -3, 4, which is right there. And then E is at 5, -4. E prime will be at -5, -4. So -5, -4 is E prime. All right, so let's get our rulers out and see what this graph will look like. So A goes to B prime, A prime to B prime, to C prime, to D prime, and D prime to E prime. Okay, what this question is asking, are there any points which remained the same after the reflection? So when we did these coordinates here, it didn't look like any points remained the same. However, if you look at this graph here, which point would be our invariant point? And hopefully everybody could see that. It would be this point here. So that point, if I was to say what that point was, okay, so the original point was x is 0 and y was -1. And then that new point, 0 going to -0 doesn't change anything, right? So that would be 0, -1. This point here is my invariant point. So which points will be invariant on horizontal reflections? The y-intercepts are invariant on horizontal reflections. And I would like star this, highlight this. Those of you that make study guides, you put that in your study guide. Okay. And again, the reason why a y-intercept is for y-intercept, remember x is always 0, and then whatever your y value is, that's your y-intercept. And what's happening is we're going from x comma y when we're mapping to negative x comma y. But if we have 0, x is 0, that does not change, right? Because we can't have negative 0, it's just 0. So that's going to be our invariant point. We'll do this summary of reflections, and then that will be the end of part 1. And I'll just put the second podcast or the second part right after this. Okay, so the types of reflections are, so this graph here was the original graph, and this is my transformed graph. So we need to say like this point on my original graph is now that point up there, or vice versa. So what type of move did we just make, right? That is going to be a vertical move. So this is going to be a vertical reflection. Okay, vertical reflections are reflections in or about the x-axis. Would be a vertical reflection. Now, what's happening with our points? X comma y is being transformed to x stays the same and negative y, okay? And then over here, the function was, I'm kind of running out of room, but y is equal to f of x was our original function. And remember that we're going from y to negative y. So the move would be y becomes negative y is equal to f of x. So that would be negative y is equal to f of x. Or remember y is equal to negative f of x. That is a vertical reflection. Okay. This graph here is going to undergo a horizontal reflection. So this point on the graph is now this point, right? So that's going to be a horizontal reflection. That's a reflection in the y-axis. That's a horizontal reflection. The mapping is x is going to negative x. So xy becomes negative x comma y. And then that will be, the original function was y is equal to f of x. And their new transform function is y is equal to f of negative x. Okay? And remember that that negative is within the function. And the last thing that you should put on this page is with horizontal reflections, write down what your invariant points are. So with horizontal reflections, invariant points are the y-intercepts. And for vertical reflections, invariant points are the x-intercepts.